Hello, sir. Good morning, sir.
Yeah, good morning.
Good morning, sir. Nice to see you, sir.
Good.
How are you, sir?
Yeah, doing fine. How are things?
Yeah, good, sir. We'll just wait for another 5-6 minutes. 11, we'll start.
No, we'll start at 11 only. I thought
Yeah.
of joining from my laptop.
Ah,
No, it is not connecting into my Wi-Fi here. So
oh,
that is easy for me because I can use my the earphones and then.
we can
Huh?
try again, sir. Still, we have time. Maybe you can call someone. Or...
No, it's maybe I'll say switch it off and then again start this.
എന്താടാ ഇനി 12 കേട്ടോ ഞാൻ അടുത്ത മീറ്റിംഗ് കയറി 12:30 വരെ മീറ്റിംഗ്.
You should switch it off. No? I'll restart this one. Interrupted, try again. Sir, this one, no? You have another laptop, no? We have. Can you give me that laptop? This laptop. Is it okay? I'll ask. Just ask him. Send it up. No, what is the problem with it? Yes, it's not here. Because I can access the Google Docs. Yes. Can I go? Yeah. It's okay. I just WhatsApp I can get in. The code is there. No, the meeting connect. I'm going to get. Can I take on that? Yeah, you can. This sir. Yes, sir. And Zoom. Zoom. Do you have Zoom? No, sir, we don't have Zoom in this one, but you can use the website, the browser link for this one. Listing ID is 843 4693 3909. Yeah, passcode last. Yeah, if it asks, then it's. Set as default. Use microphone. Huh? Hello, I'm visiting this site. Yes. No need to set as default. The imaging passcode is 1555 829. Yes, sir. Yeah. Yeah, Dr. Sujan. Sujan, can you hear me?
Sir, we can hear you, sir.
Yes,
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 yes.
yes.
Because I joined from my laptop, no? So
Yeah, yeah, very much clear.
Google can go, no? It's not coming. There is some video. Oh, I see. Okay. I think I can see that now. Oh, sure. Only that. Only this. No, both mouse and keyboard. That also, that can also. No. Then I'll just dongle have to connect here. No, let it be there. I think I can access them here from here itself. No? Yes, sir. All those documents. You can't use this. No. Google Docs. Yeah, you can use that. This, can you just see that? No, it isn't. Let me see. But,
Hello, sir.
Hello, sir.
Yeah, can you? Yeah.
Yes, yes, yes.
Yes, yeah.
Yeah, I think you are comfortably logged in your laptop.
Yeah, now I'm using another laptop because I have the Mac. It is not somehow getting into the network. No? Okay.
I think, shall we start, sir? Are you ready?
I'm ready. No, I think I thought of sharing my experiences to begin with.
Yeah, yeah.
Yes,
I think
sir.
Krishna will start, then we can continue.
Yeah.
Yeah, we can see where we can really pitch in. The presentations. Okay, they'll be sleeping. Because at least if I'm talking, probably they'll be listening to me, right? And they can ask me anything during the talk also.
Yeah, yeah. Krishna, next we can formally start. Then,
Yeah.
as we go, maybe sir also will have interactive sessions. Will also be online. Or to Krishna.
So can we start, sir? Yeah. Yeah, sure, sir.
Okay, yeah.
Okay, sir. Okay, sir.
Meanwhile, I change the system. Please make me in the co-host in the new system.
Okay, sir. Sir, shall I start, sir?
You please start there.
Okay. Okay, sir. Okay, sir. 1 minute, sir. So, a very good morning to all our wonderful participants. Welcome to day 3 of the FDP, Building Entrepreneurs from Campus, Case Studies and Practices. We are now at the halfway point of this 6-day journey, and the learning only gets richer from here. Today's theme is the science of protecting and validating your innovation. 2 sessions that are absolutely foundational for any serious entrepreneur or faculty innovator. Session 5 brings us a legend of Indian manufacturing research. I'm honored to introduce Professor N. Ramesh Babu, V. Balaraman Institute Chair Professor and Secretary of Advanced Manufacturing Technology Development Center, AMTDC, at IIT Madras. Professor Ramesh Babu received his PhD from IIT Madras in 1990 and has since built one of the most distinguished career in manufacturing engineering research in the country. With over 61 international journal papers and 104 conference papers, he is both a prolific researcher and a dedicated mentor who has guided over 22 PhD scholars and over 100 postgraduate students. At AMTDC, he has been at the forefront of converting research into industry-ready technology, which is precisely what his session today is about: IPR and technology transfer. For every faculty member who has invented something in the laboratory and wondered, what do I do with this now? Professor Ramesh Babu's session today is for you. Ramesh sir, we welcome you warmly. The floor is yours.
Yeah, thank you, Dr. Krishnan Unni.
Thank you, sir.
For a very nice introduction. And let me greet all the participants. Very good morning. And I'm going to take some time to narrate my own journey in the research and developmental activities at IIT Madras. And before I joined this IIT Madras, I was also working at the national, our ISRO, which is the strategic sector space agency, as the scientists see, for a brief period, and then moved to a multinational company in Delhi for again a short stint, and then joined IIT Madras in 1983. So 1983 to 2023, I was at IIT Madras as a researcher come faculty member. And then 23 onwards, I have been serving as Professor Emeritus. And of course, I will also give a brief on how we have started this Advanced Manufacturing Technology Development Center.
as a not-for-profit society in IIT Madras Research Park. I think the journey has been very, very tumultuous and troublesome, and at the same time, I enjoy doing work. That's how I have been able to build, and I continue to serve as the Secretary of Advanced Manufacturing Technology Development Center. And why I wanted to talk about my journey is that is unless we build several leaders in the area of advanced manufacturing, the Vikshit Bharat goals will not be and cannot be met. So I think this is where my journey is going to be a case study that illustrates, the ups and downs of a researcher, and also as a startup. It is like a startup to take up this startup and then continue my journey as an entrepreneur in order to bring the money and pay every bit of our center, right from the rental, lease, and also the salaries of people, etc., is going to be very, very useful to all of you, provided you have that sort of a passion and a fascination to see that we all wanted to build such centers of excellence at various locations in this country. And that's the need of the hour. That is what the government of India is also anticipating. That if any successful model is seen by anybody, they would like to immediately emulate it and see that such centers of excellence can play a vital role in building the technology and then building the manpower and making this country as an advanced nation, as a superpower in course of time. When I talk about the journey, you might wonder that how did you choose this at the beginning? Like I didn't choose it, it just happened naturally. And only thing is that you need to have that curiosity to know, curiosity to learn, and a passion to experiment, and that sort of a determination to continue irrespective of the difficulties and then blocks that you will have constantly. I'm today serving in various committees as a member at the national level in both, the aerospace and also in the DST, both national and international divisions. And many projects were sanctioned by the agencies and to various colleges and institutions. It's not to demean anyone here, well, are seen to be very, very low. And even those levels are not being pursued further to see that, the technology is eventually developed. That is where the story that I'm going to narrate may be useful to all of you to at least experiment it if possible. Otherwise, join hands with somebody else to see that, this mission is really made possible. And think that the manpower is also developed equally well in order to shoulder this responsibility. So I know that all of you have come from different colleges and different institutions of repute. And if you want to really maintain this reputation, in my opinion, each one of you should take a oath that I'm going to build at least, 100 people who can really serve in various national laboratories as well as the companies, which are being set up in India, either a small, medium, or large-scale industries in different sectors. One of the problems that we are all facing in India is that the leaders are not available in the areas like manufacturing, AI, ML, IoT, robotics, and digital transformation, etc. So what do you mean by a leader? Leader is not to follow someone who has already done something. But unless you follow somebody who is a model guru or a model person as a leader, so it is also difficult for you to innovate on your own. So if you start innovating it, probably it may take again 3 decades or 4 decades for each and every person. So in my case, as I told you already, it is more than 4 decades. So if someone is going to take again 4 decades, I think we are going to build only few handful of people who can really become the leaders, and that's too small number for the country of this size in terms of population and then economy and the expectations of our Prime Minister Modi ji on Viksit Bharat, etc. The next question is whether we want to really do, or we can be happy with whatever we are doing it. I think you can be happy with whatever we are doing it. But then who is going to be the loser? You may not be the loser directly because you are all placed in some institutions as some faculty member. But the losers are the next generation, and they may be your own children or your own grandchildren. I think we will be doing a lot of injustice to the next generation by not emulating the good models available in this country itself. I think in that context, I felt that it is my bounden duty to share my experiences sincerely without any bias or prejudice or any excitement, because I have reached a stage wherein none of them is going to give me any greatness in my own sustenance as well as the survival. Because when you come to the fag end, you wanted to see that your next generation is likely to enjoy more than what you have enjoyed it. But let me frankly tell you that throughout my journey of 4.5 decades, 80 November, I have started my journey at ISRO. And then even now I'm continuing it for a couple of more years. I'll serve as the emeritus, and then if everything goes well, then maybe in some role to help the nation. So I think in that context, you might ask that what is the difference between the IPR and startups and entrepreneur? So let me begin with 1 or 2 case studies which I have experimented it and then taken it to the technology transfer. So the IPRs are nothing but some inventions. I think we all know every day in India so many inventions which are made by our own ancestors, but none of them have been brought to the notice of IPR cells and IPR departments. But today, everyone is being viewed as their intellectual property. I'm sorry, yeah. Because the inventions are nothing but something novel which nobody could do it in the way that you have done it. I think I'll take the first activity that I have done it at ISRO. I was working at IAC for my MTech ME, we call in IAC, ME project on micro machining. This was in 1979. So my professor has asked me that if you want to really, those days itself, he was thinking of optical lithography. Optical lithography means if you use the mask and then use all those photolithography by using the mask of a very large size and then condense it to a small size through the optics. So that we call it as an optical lithography, wherein you are making a mask with so many circuits and various electronic devices, and then etch them on the silicon substrate. So he felt that if you can directly make this etching by means of laser, and lasers also have visible spectrum to the infrared spectrum to the ultraviolet. As the wavelength becomes smaller and smaller, then you can focus.
Sir, are you missing any presentations, sir?
No. I'm not giving any presentation today.
Okay. Go ahead.
Just I will go a little later. So
okay.
And this etching, I have several presentations. I thought I will narrate it through some of my experiences,
Okay.
and then we will see how to. Then they can ask me the questions. Then I can respond to that one. Then it will be interesting for them also.
Okay, sir. Okay.
So if they remember some of these points only, they can ask me some questions. Otherwise, they'll be simply
Yes.
just looking at the slides and then listening to me. Okay.
Okay.
So this is what my professor has asked me at IAC.
Your video is also off, sir.
Yeah.
Your video is also off.
Okay. Now let me switch it on. Yeah. So he was asking me whether I can make the laser as a especially clean beam. Normally, those of you who are working in the lasers, they know that when the lasing happens and the beam comes out of it, it will have a transverse electromagnetic mode, TEM we call it, 0, 0, 0, 0, 0, 1, etc. So once it comes out, you can see the beam. That means, we were developing the lasers at IAC, ND glass and neodymium YAG lasers. And when it comes out, it was having a dot at the center. That means it is called the, donut beam, DONUT. Donut in the sense like our donut. So you will see some sort of a low intensity, because of which we focus it onto any substrate, you will see the same dot without removing the material. So he said, how do you spatially make this one into a Gaussian beam? I think all of you must be aware that the Gaussian is a distribution where in the center you will have the maximum intensity, and as you keep moving towards the ends, that will slowly taper off. So he has also given me some ideas that how to make it into a clean beam by putting some apertures, some pinholes, and we did all of them and we got a clean beam, but the intensity was dropped to almost 50% or 25% only. Then he's asked me, if you focus it, then you will get a focused spot in having the same Gaussian intensity distribution. I did that one. Then he said, okay, why don't you make a precision stage? It is called the micro positioning stage. Oh, you know that micro positioning in the sense you should move in terms of a microns, not 10 microns or 25 microns, which we do it in a normal stages. So you should think of some stage, it can be a small stage, and then start doing it. So what I did was I went to various people whom I know in ISRO, a scientist who used to come to IAC library. I used to interact with them. They're all from the optics background. And then when I started interacting, this problem is very difficult. At the same time, you can try it out. And then he has asked me how to make this stage. And it is only micrometer actuated stage I built it. And I could really use some feedback as a spring in order to resist the motion. So for my project at the ME level, I have produced three things. One is making the beam clean, and then making the stage with only 25 millimeters movement, because the micrometer actuated screw which is fitted, and then we moved it and we have got a guideways in which the balls are moving. Today we are talking about the many ball screws where the balls are being circulated through some cage, etc. So similar one, which I didn't even know what is recirculating ball screw those days. And then I just put two V grooves on either side of the stage, and one is moving and the other one is fixed like guideways. So what I'm saying is, I think we have to create that sort of a curiosity in the minds of young students by giving challenging problems. And finally, what I could do is I demonstrated that by moving it in a straight line, I could engrave a line to some depth, which again depends on the depth of focus of the lens. So once we did it, then he made his own paper, etc. And of course, as a ME student, probably we may not, write all those papers, but then he did everything and then acknowledged my work. And it was very gratifying and fulfilling for me. Then I went to the ISRO as a scientist C with this background in the lasers, because I studied almost all the books in the solid state laser engineering by Koishner, then Jan and Wolf, by fundamentals of optics as a mechanical engineer, and precision engineering, and then lenses, the aberrations. We looked at the chromatic aberrations, spherical aberrations, coma, astigmatism. What I'm saying is, as a mechanical engineer, I have learned all of them during my ME, which could really give me the confidence that when I go to the ISRO also, I can take up some technology development projects. So they were using the normal autocollimator and the theodolites. They asked me, why don't you develop some laser autocollimator? So again, that experience was very interesting and then fulfilling. Again, I stayed only for 1 year, 2 months, and decided to move out for some reasons. saying that, okay, let me experience it in the industry. I went to a multinational company, again as a laser engraving engineer. So they bought the machines from Germany and also the microprocessor controlled systems from UK, and the experts have trained. So, and all this training has made me to think that whatever we do should have some sort of a purpose. The purpose is I just assembled all those units in the company as a system integrator along with the experts from the countries. Then those machines, like production machines, we started producing the rubber printing sleeves. We call them as a flexographic printing sleeve, and which is about maybe 4 inches diameter and 72-inch long rubber sleeve. So the sleeves were manufactured in India, but the equipment came for laser engraving. And on one side, the artwork will be there. Whatever you wanted to produce it on the dress materials and shirt materials, and you take the gray fabric and put this paper which is printed with different colors and then transfer. That's called the transfer prints. You might wonder why you are saying all that. That means this is the experience that gave me that whatever we do it, I think there are so many challenges which we have faced it during the entire period of 1.5 years. And I used to manage this entire laser engraving section and also the various designs which were given by the artwork department, etc. So the gaining an experience in a variety of fields in a short time will also give the student or give the faculty members the confidence that we can really learn more and more. Instead of teaching the same course and doing the same work and showing reluctance in moving from one area to the other area, I think this is the fundamental learning from this one. In the sense, you need to have that sort of a curiosity to switch from one at that. And the number of books that the professors used to prescribe those days, Professor L.S. Srinath, Professor Soundarnayagam, they're all stalwarts. They used to ask us to read textbooks from the library, and we used to take them on loan and then do it. I think this is where the intellectual property generation requires enormous amount of a passion and determination to work on anything and show the result to the guide or advisor or anyone who is helping you. I think this is where I have been seeing the projects which are being given to many of the institutes through the DST and other agencies are not taking up the real shape because the people who are involved right from the top to bottom, the faculty members, the coordinators, and the research team and the students who are involved in that one are not having that sort of a clear-cut path to see what are the deliverables, what are the outcomes, what is the level to which they have to go. I think this has to be really made as one of the prerequisites for every faculty member while assessing their progress or promotions and various things. I think, are we really doing it or not is the question. I think as a member of several committees at the CMTI and many of them, I used to say that if the scientist has not that a passion at the beginning, I think it will become very difficult for them to become the world-class scientists are capable of producing any of them. And today's entire ecosystem is going in multiple directions and making the faculty as well as the students to think in different directions with a very little time and with very little effort. So they keep moving from one to the other to show that I have set up this one, I have done this one, I made this one, etc. So I think this is what one should first think about it. The second one is I came back from the multinational company to the IIT, and I didn't go to the mechanical engineering because there was a position in the senior project officer grade 2. In those days, it was like a 700 to some 1300 or 1600. So I took it up with a few increments, and that professor is a physics background and mine is mechanical. And the team members are also with optics and some physics background. So I studied them. And today, that lady who worked with me as a project technician, she is the Vice Chancellor of VIT, S. Kanchana. What I'm saying is, the passion with which she moved from the diploma to the part-time BE to the ME to the PhD, and today being the Vice Chancellor of VIT is not a small issue at all. And in the same way that I moved out of physics department and went to the mechanical engineering, I wanted to pursue my PhD. So I asked my professor that I want to work in the lasers and laser materials processing. That was one of the very, very pioneering area emerging. And I happened to visit a few laboratories under some sort of a program wherein the company which supplied the lasers offered a training for 1 week to 2 weeks. And my professor was kind enough, Professor Y.V.J.S. Murthy, he's still alive. He's in Mumbai, 88 or 89, I don't remember exactly. But so he encouraged, the people like me with so much of passion. I built the labs, I made the dark rooms into the clean rooms and, the air-conditioned rooms. In the sense, that is the dedication with which you have to work with a lot of discipline right from the beginning. In the sense, if you are disciplined, and if you are passionate, and if you are determined, and you are sure to succeed in your attempts. So the innovation, how the innovation comes into picture. So my professor has asked me to work on some problem which is not solved by anybody. There is no literature available. He told me that if you have a laser, can you use the laser to scribe a line? Since I had an experience at IAC, immediately I have put the lens and I had a small stage, on the optical bench. I started moving it and then produced a groove on the grinding stone. The grinding stone, in the sense, he gave me a piece of a grinding wheel which is broken. So when I did that one, immediately he asked me, you build a setup, and that setup is basically to truss the entire grinding wheel, which is a large grinding wheel, not a small grinding wheel. Then I have come up with some sort of innovative ways of solving it. It took a lot of time for me to build the setup in 6 months or so. And today it appears to be very small or very large, depending on the team which is working on it. Then that setup was used in order to truss the wheel. I think that was my PhD topic on laser trussing of grinding wheels. You can also find them in ASME Journal of Engineering for Industry, August 1989. 2 parts, because when the entire paper was sent, the reviewers gave so many comments. I took them sincerely. I took about 6 to 8 months in order to address all of them. The paper length has gone beyond the limit, and then they said you split it into 2. So part 1 and part 2, you can find them in the ASME Journal of Engineering for Industry. So I am telling this one. So it was a concept, the idea which is given to me by my professor. I just made it work. Then I started developing other setups in order to declog the wheel which is loaded with aluminum chips or austenitic stainless steel chips. I think this was the real application which we took it up. And then we have really solved this one. And again, it is TRL3 to TRL4 only. Then one Professor Ranga Komanduri from Oklahoma State University, he set up lasers, and he was also at the NSF, he was also at GE. So he came and interacted with our Professor V. Radhakrishnan. Asked me if you have really set up following things, and he's asked me to work on the flexible way of dressing the wheel. Right now, we are rotating the wheel and then moving the single point dresser, diamond dresser, across the wheel width, and it produces somewhat helical groove. You don't have to do the helical groove. You can have at an angular axial dressing. So I did that one. So why I'm saying this is, these are all the small ideas which will come up to everyone. Even today, there are so many ideas you may have. And by looking around and looking at the problems of the society, the agricultural area, then food processing industry, or the various industries nearby, like we were also talking about, some foundry or, some industry wherein they may be facing in terms of lot of wastage or lot of an energy, inefficiencies, etc. So that means the problems are available, and those problems have to be collected and then taken up at some priority level. If some infrastructure is available, if some people are going to give you some help in solving these problems, in my opinion, we should involve the young students to carry out those problems. So what happened was, after a few years, this was 1990, I got my PhD. And then after 10 years or so, he was interacting with the CMTI, which is located in Bangalore, Central Machine Tool Institute. Now it has become Central Manufacturing Technology Institute. So their director one day called me, Professor Ranga Kumanduri is here, he would like to get involved in some projects. Then I asked, what is it? So it is a laser dressing. Why don't we make it as an attachment on the cylindrical grinding machine? And that machine was bought by them. And they are using the normal single point dressing or a multi-point dressers for dressing the wheels. Then I just went there. Then I interacted with them and said that, no, we'll buy the laser, which is the latest one is the fiber optics. Those days I used the ND YAG laser. The compact ones are coming up today, and fiber optic laser, and we bought it. And we made the optics, we made the attachment on the machine. Now you can imagine that is called the TRL-7. So from TRL-34 to TRL-7, it took almost 10 to 15 years for me to experience it. And there are so many other examples which I can narrate, but then would like to skip this one and then go to the next one. So then in 1994 or so, the Tamil Nadu Minerals Limited, Tamil, and they approached our dean and said that we wanted to look for an alternative technologies for cutting the granite. They were using the diamond wire saws. And we went through the literature and found that the water jet cutting was emerging. And we found that the abrasive water jet cutting is going to be a better way of reducing the pollution. Because when you are cutting the granite stones of different kind, the pollution levels are going to be very high, because the dust that is produced during the cutting of the granite with the diamond wire size very noisy on one side, and then a lot of dust also is causing some health hazards to the people who are operating it. So we visited that. Then we proposed that we will attempt to use the water jet technology, for which we thought that we will import abrasive water jet cutting machine. And of course, there was a lot of resistance from the DST. So high-tech institutes like IIT should develop the water jet technology machine. But we were not having any know-how. So what I am trying to tell you is, in case if you are venturing into some area where you don't have any expertise, it is always better to look at somebody who has that expertise, or some machine which can be replicated through the reverse engineering. So we should not worry too much about, oh, we are doing reverse engineering, it's not innovation. But then the innovation comes once we re-engineer it. I'll tell you the story of the water jet technology also. So then what happened, we used this one and showcased the benefits of a high pressure abrasive water jet technology. And that was going on for almost 10 years. But then meanwhile in DST, there is a program called the International Collaboration Program called DST DAAD program. Even today it is there. And they'll invite some of the scientists, and for invitation, you should have some sort of a contact. So from 94 to 98, when we were working, and one scientist, Mohan Vijay from National Research Council, Ottawa, Canada. So he found that I am working in this area. And when he went to IAC, so immediately told there is one professor, he's working on that. Then he wrote to me. Those days we used to go through the FTP, and the email connections were very, very less. So then I responded immediately. There's one Professor B.V. Rao who retired from IIT Madras, went there as an advisor to many of them in Bangalore. So he immediately contacted me. So what I'm saying is, you should never hesitate to grab the opportunity. So I took it up, and we organized International, 5th Pacific Rim International Water Jet Technology Conference. Probably you can see the proceedings also online. And myself, BVR Rao, Mohan Vijay, all three of us. And there's one Professor Jagadish who is at IAC in the gas turbines or a propulsion, that area, combustion area. So we were working together in order to organize this one. And that gave us some clue of interacting with these experts. Then one Professor Hartmut Lewis from the Hanover, University of Hanover. I wrote to him and immediately responded that yes, we can have a collaboration. So I just went there for 2-3 months, 99, 2000. And during that time, a lot of papers are available in the laboratory. So I just took copies of some of them. And I thought of making a proposal on a water jet cutting using the slurry type of jets, on which the team already working at the University of Hanover Water Jet Laboratory. So I think, can you imagine that these sort of small things, if you hesitate to move on, oh, I have conducted the conference, succeeded, I got my promotion and everything is over, so why should I really work? And this was 99, 2000. 2000, I became a professor. Then afterwards, I thought, no, okay, I have to pursue a different line. My professor always used to tell that the professorship is only a position and you're moving. But then you have to work aggressively if you want to really develop the technologies and make some innovations. And from 2000 to 2002, we have been working on the proposal. So those days, we wanted to think of adaptive control using the soft computing approaches for water jet technology. So I think I guided a few of them, and some of them, like a John Rosaria, who is the deputy director at DRDL, and he was all my student. I picked it up from the MIT when he was doing some work for a company in Pondicherry, Whirlpool. So you need to identify the right students also to carry out your work. And after that one, you have to encourage them through the fellowships or some contacts and other things. And even he wanted to leave in between, but I didn't allow him to leave because of some family compulsions. But then you see today he has taken up a responsible position in the DRDL, working on all types of missile-oriented projects, etc. So I think you see the building the nation and fulfilling the Viksit Bharat is not going to happen just by mere teaching or a research. And these are the innovations. We developed our own abrasive focusing nozzles. So a small steps gave me the confidence that we need to go in a bigger way. That adaptive control project also gave me a lot of confidence that even with the international agencies, and that was funded by the Volkswagen Foundation, almost 100,000 euro and 198,000, 198,000 Deutschmarks. So what I'm saying is this sort of a collaborations and interactions and meeting the right kind of people is essential for the faculty members during their leisure time, during their holidays, etc., etc. So I think then what happened was around 2004-05, I happened to meet someone from the Saint-Gobain. They've got a Norton grinding wheel company in Bangalore. And they were looking for some collaboration with IIT Madras. And then they asked our Dean, Professor Krishnan Balasubramaniam, and a few of them that whether anyone is working on the grinding. Then immediately they sent me a mail. I responded. And one Dr. Subbu Subramaniam, who was the director at Northborough in Saint-Gobain. So he contacted me. So I'm coming on so date to India. If you are available, then we'll set up a meeting, etc. So in 2006-07, we started interacting. And he said that we can fund you, and we wanted to set up a Saint-Gobain Research India here as one of the centers in the next couple of years. And that also gave me the confidence. Yes, I think we should take up some of the research activities. I think meanwhile, what happened in 94, the Amada company from Japan, who is producing the sheet metal machinery, product manufacturing machinery, like punch presses, press brakes, laser cutting machines. They came to IIT, interacted with the Professor Radhakrishnan and myself. And immediately they said that we wanted to hire some people from IIT to set up the Amada Soft. And that took almost 4 or 5 years for them to establish the software activities in sheet metal product design and manufacturing. And I happened to interact with them on several projects in building the nesting algorithms. Again, you can see computer-aided design 2000, 2001. The same namesake, K. Ramesh Babu and Ramesh Babu. We brought out a generic approach for cutting any type of parts on any type of sheet. So what I'm trying to convey here again is that you should never hesitate to move with anybody. You may not initially get any benefit from them. After 10 years only, they realize that we have been helping them in many ways by doing the research for them and giving some sort of a support in terms of the manpower. And the management from Japan came along with their president and interacted with our HOD and myself. And finally, they said that we are going to set up a sheet metal research center at IIT Madras in your lab. So we could find this space and then set it up in 2008 along with the AMTDR conference. And then we have run that center till recently. And the Saint-Gobain came in 2008 and we did that. So in each and everything, the job that we wanted to do is relevant to the research. But then that resulted into some sort of innovation, some patents. So if you look at the number of patents that we have produced on the actual manufacturing related area, in abrasive water jet cutting and grinding, it's more than 15 to 20 and even international patents. So the IPR will not just like that come unless you start working with the industry, understanding their problems, started working with the society and realizing the need for such problem solving. And that has resulted into IPR. And from 2006 to 2008, the Indian machine tool industries and also the government of India, principal scientific advisor, Dr. R. Chidambaram was the PSA at that time. And so he promoted the manufacturing related research. And so they gave us the project in 2011. And again, it was an accidental move. One of the managing directors of the ACE group, that is called the Micromatic Grinding Technologies. They produce the cylindrical grinding machines. And ACE Designs will produce the CNC lathes. So he came to Chennai Trade Center here and asked me. Again, he came to know through Dr. Subbu Subramaniam from USA that so-and-so person is working on it. Why don't you meet him and then try to explore some collaboration opportunities? And then immediately Mr. Dand called me and he said, if you're available, I want to come and meet you on so-and-so day. So it so happened that he was busy with his entire business in the Chennai Trade Center and he had to catch the flight at about 4 o'clock or 5 o'clock. Then he said, next time I'll meet. I told him, I'll come and meet you. So immediately I went to Chennai Trade Center. I spent 1 hour. In the sense, when you have something to share, when you have something to explore, collaborations, I think you will move forward. And that comes only with confidence and when you do some IP, etc. Otherwise, you think, why should I go there on Saturday and then waste my 2 hours time and after that we may not get it. But then that around 2006 to between 6 and 8, this has happened. Then we prepared a proposal with the 4 agencies. One is the Saint-Gobain and this Grindwell Norton. They said they'll supply the wheels, and Micromatic Grinding Technology, Indian Machine Tool Manufacturers Association. And when we submitted the proposals, many of them have rejected it, saying that they don't have any expertise in building the machine. But then we replied it, and since we have 4 people really very strong people with a lot of experience. So 2008, we submitted the proposal. It took 2 years for us to get this proposal. 2011 only we got it. 11 to 16, we have built it. And we have 3 patents on this grinding machine, cylindrical grinding machine. And those patents were also used in order to transform the machine into a next generation precision grinder. I think I used to share this one in many conferences, Kopan at NIT Calicut, and also in Kopan in IIT Bombay. So I think I used to give these lectures in order to really encourage many youngsters to work on that one. But then today I thought that these are the experiences which made me to collaborate with the multinational companies from Japan. I was a consultant for almost 20 years. And even today, we still have the collaboration, and any Japanese delegation comes, we are there. So you can imagine that as a student at IISc in 1978 to 80, if I could really come up to the stage is not by means of any support from any of them. I failed in many occasions. I got frustrated on many occasions when we applied for some awards and the fellowships, but I never stopped. I continued to work on that one. And 2014-15, we could really make a change from IPRs, intellectually property patents, to the technology transfer. I think it took 1.5 years for us to prove that machine is capable of producing the parts on par with the machines being imported. Just imagine the small ideas have been converted into papers, then patents, and to small attachments. So the technology readiness level has moved from the 3, 4, 5, 6, 7 to finally 9. And at that time only the principal scientific advisor has interacted with many of them with all the inputs taken from our project. Then I think he's one of the prime movers to promote this sort of enhancing the capabilities of Indian capital goods sector. And the scheme was launched in 2014 November with a pilot grant of about 550 crores. And today, several centers are set up as common engineering facility centers. And ours is the center of excellence. Then Samarth Udyog, basically it is now Industry 4.0. Then additive manufacturing. And many centers have been set up with the initial grant, by the Ministry of Heavy Industry in a shared model. In the sense, unless they put 20%, government will not give the 80%. There are so many other schemes, we have seen it like Imprint, Vichitra Avishkara Yojana, but then some are successful, some might have brought out some results, etc. But my experience with the capital goods scheme was very phenomenal, because 2014 to 2020, until the COVID has hit us, we interacted with the 6 industries, putting up their money, about 20%, which is about 11 crores. And we got 4 times that one, about 44 crores. That means with 56.125 crores, our projects were sanctioned in 2015. And then we decided that by taking this money, developing the prototypes, and converting them into patents and copyrights, we have done several projects, and which range from making the machine into a precision machine, high precision machine, using some sort of a thermal compensation strategy, and we took the copyright also. Then we are also using the technology innovation hubs, where we wanted to promote this one is a cyber based systems, and that also we did it. And then we went into the platform wherein we can connect the people, that is called the KITE, the digital platforms. And then Secretary Mr. Arun Goyal, who wanted us to work on the real training for the students during the COVID, and we offered online training for many of them. And with the efforts put in by the students and the mentors and many of them, we have built some sort of a fruit harvesting machine here. And there are many such success stories which I can share it. Probably if you, after a few questions, then I can show some of these presentations. Today, what is happening is the second phase of the CG scheme is also going to be over by next year, March 2027. And very recently, for the last 1.5 years, we're working on the mission mode activities in advanced manufacturing systems. What is this mission mode? Like, unlike the projects, unlike the scheme, as I said, the scheme is nothing but the capital goods scheme. And there are several components like setting up the facilities, setting up the Industry 4.0 activities for training and skill development, and additive manufacturing and the technology development centers. And now they wanted to scale it up. And to scale it up, they wanted to utilize all these centers and facilities and the expertise that is created at the national level to make it to multi-fold. It's not 1 crore or 2 crores, 10,000 to 20,000 crore for each of them. The 4 groups were identified, and one of them is the CNC drives, control systems, even motors, ball screws, gearboxes, or anything which is useful to build the CNC machine tools. The other group is working on the robotics, and we want to work on the industrial robots, not on the mobile robots or cobots, etc. But anything that is useful for the industry in the auto sector, EV sector, defense sector, aerospace sectors, I think all of them are interested in the core technologies, aggregate technologies. I think that is another area. The third one is we need to have additive manufacturing related activities. I think even from the VSSC, a few of them have come, and all of them have presented their requirements. So at the national level, we had a meeting very recently, and that's at the Principal Scientific Advisors Office, wherein all the secretaries from all the space, atomic energy, the CSIR, all of them have come, DRDO. They all felt that there is a need for us to launch this mission mode activity as soon as possible. And we are also working on that one. Today, after this meeting from 1:30 to 3 o'clock, we have something else to discuss and then finalize it. So what I'm saying is this mission mode is not meant for AMTDC or anyone. Suppose if you can emulate these AMTDCs multifold at various places in this country, and for which we need strong leaders, and we need the collaboration partners, industries, and we need many strategic sectors and the MSMEs. So I think our activities are in the 3 directions. One is do research at the TRL 1 to 3 with the funding from the ANRF, and TRL 4 to 6 with the RDI fund, Research Development and Innovation Fund, which is 50-50. Industry has to put in 50%, and the research institution which is pursuing it should also actively participate it and then produce the new products or new innovations. And the last one is the PLI scheme in manufacturing, and also the capital goods scheme enhancing whatever we have done it over the last 2 phases. It will continue to support it. That will be TRL 7, TRL 8, TRL 2. So if you see that the DST also very recently decided that they would like to support the projects through the centers of excellence. The reason is in the centers of excellence, there will be at least 10 people who will be working, or 6 people, faculty members from different areas. So if they come from different areas, even if one person leaves, the others will be taking the responsibility of running the project and completing and delivering the results. I think the entire scenario in the country in terms of funding opportunities are changing, and the innovations have to be made into technologies, and technologies have to be utilized in this country itself for building the products and then making it. Of course, if you go to the Niti Aayog also, you can see the reimagining the manufacturing. The report was also brought out by the CII into September 2025 or so. So I think this is where the awareness of what is happening in the country is important for each of the faculty members and the administrators and the institute, the leads. So please remember that I'm not just giving for the sake of giving it. I can show how we have transformed. So maybe you can also visit us anytime, and I'm here to support, and we have a team of about 30 people, and there are some people who are leading, and they can also help you out. And we are helping a lot of young students from Tier 2, Tier 3 colleges in order to make them aware that what we are doing is going to be useful for the country in maybe next few years. And if possible. And if they are interested, we would like to help them in incubating their ideas and promoting them on different aspects like drones, autonomous mobile robots, or anti-drones, etc., etc. Please remember that building entrepreneurs and building the next generation leaders requires a passionate way of dealing with them, passionate way of working at each and every institute. And unless you see somewhere, I think earlier we used to send people abroad, but I think it is not required today. We have several institutes where you can gain that experience, and you need to translate it very quickly to transform the institutes and colleges and the individuals. I think this is where we used to call translation and transformation. Unless you have that idea of translating that into products and small prototypes, then start venturing into the startups and ideas. I think it's not really going to bring out a change in the entire manufacturing. I think the manufacturing is going to be one of the areas for every field. Either you take the aerospace or electric vehicles or semiconductors or defense sectors. Please remember that the employment generation is possible only through this entrepreneurship and through the innovations that can happen in each and every area. So I think I have taken some time to elaborate it, and half an hour is there. Maybe if you want, I can always show some of them depending on the interests of the people. And very
Maybe
recently,
if you are sitting in AMTDC, maybe a look around of that, or maybe
we can show any of them. So that's also
that
possible.
will be highly useful for them, because that much a very production center with the research laboratories and all.
Yeah, if you want me to share some of them also, I can share. Okay.
Yeah, that is better, sir, because that's a very high precision labs and production system you have. And also that is a realities which probably I would expect, as I also, Krishnuni and Thomas, we all visited your labs in.
Yes. What I can do is I'll just make this entire presentation. Okay. So I'll go through this.
Meanwhile, if any of the participants, if you have any questions, either you put it in the chat box or you can unmute and you can ask.
Yes.
Please.
I want them to interact, for a couple of minutes.
Please.
Then I can make this presentation.
Next 3-4 minutes, we will wait for the participants. Any questions you please ask.
Yes, please. Please feel free. Don't hesitate to ask questions. If you don't ask questions at the beginning, then there's nothing we can do together. Okay.
I think they will get ready. Meanwhile, you can also type in the chat box by any chance if you have any difficulties. Meanwhile, sir, you can also start displaying your laboratory.
Yeah, I will do that. Yeah.
Yeah, okay.
Sir, there is a question in the chat box.
Yeah, just 1 minute. I'll ask my
Sure.
people to connect it, so that. Yeah.
Okay.
Meanwhile, others also can put questions in chat box.
Yes, didn't present anything. So only this.
There is a very big laboratory as well as a production center.
This presentation we used to give it in.
Yeah.
How do I
You can
share it?
just email one of the emails. You can just enter here.
Dr. Sojan, can you give your email address?
Principal at
Put them in the chat, sir.
Chat box. You can put it so that
yeah.
I'll share this presentation, which you can.
Krishnani, you take it.
Yeah.
Yes, sir.
You can display from there. He'll give his.
Yeah, I will send my email ID, sir. 1 minute.
Meanwhile, you can CC or to me also. Can see.
What is the,
Yeah, you can send the PPT to S.
Principal.
Krishnanuni at
Both
JACC.
you
Yeah,
can
both.
send it.
Yeah.
S.
Yes, sir.
Krishnanuni and principal at jecc.ac. We can CC that also.
yes, Krishnan Unni, okay.
You can just
Yeah.
copy.
Yes.
Yes, Krishnanuni. So somebody is asking also whether you'll be able to share the presentations. If you have. Yeah, we'll go through that first.
Yes, sir.
Yeah, I think I'll
First-
go through this one first in the next half an hour.
Yeah.
Then you can, principal.
I'm sure that it will be an exciting presentation because being a professor at IIT Madras, he has done such an extensive works, developed so many systems, and his own laboratories,
Yeah,
production systems, all world-class systems.
yeah, I think Krishnan Unni, I have shared it with you and also with the principal.
Yes, sir. I have received, sir. I will share it.
So would you like to just share it?
Yeah, I will share it, sir. 1 minute, 1 minute.
Yeah, Krishnan is coming. Yeah, correct. Sir, you can go ahead.
Yeah, I think we'll go to the next one. Can you go to the next one? Yeah. See, whatever I have talked over the last 1 hour, there were many. We started with small experiments and then finally went into the attachments to the machines, etc. But one of the major activities that gave us the fillip to start this Advanced Manufacturing Technology Development Center is the next generation precision grinder development, taking about 3 patents on the know-how that we have generated and carrying out the rigorous trials on the machine with 3 companies giving their components with the tooling and showcasing the results on par with the imported machine is the precursor to the establishment of the AMTDC. So then we focused on several areas in the scheme that was funded, that funded us. Similarly, the other IITs, IASC were also funded. So I'm sharing the areas in which we have worked and various projects on which we have really carried out, several works. Can you show that?
Sir, 1 minute, sir.
We'll go to the slideshow.
Yeah, slideshow right now. This one.
So this is where I think we didn't want to take up this as a project. This was a pre-competitive. They were not expecting any product out of it. But if you do the research and publish papers and take patents and train people, that's more than enough. But then the committee which was formed to review this project periodically was very rigorous. Professor N.K. Mehta from IIT Roorkee and Professor P.V.M. Rao from IIT Delhi, then Dr. Balasubramaniam from BARC, and Mr. Neeraj Sinha from the Office of the Principal Scientific Advisor, and Mr. Mohan Ram from IMTMA. I think all of them have shown, and there are many of them who used to periodically come and then review the project every 3 months. So as you see, all these participants like Micromatic Grinding, STIMS Institute, Advanced Machine Tool Testing Facility, IMTMA. And what we wanted to do is we wanted to bring out a framework that can help the young faculty and entrepreneurs to make these machines into precision machines. I think if you see the bottom line, to identify the technical pathways, what IITs and institutes can do is, we cannot make the machines within the institute, but I can give the pathways so that they can do the work and then test it and validate it. This is what was done. And in this process, we also identified the strengths and weaknesses of the machines, and we build this machine. I think with this introduction, I'll quickly run through a few slides because that gives you, even if I spend more time also, you may not appreciate it, but then I'll highlight a couple of points in each slide. Next, please. I think this figure looks very confusing to many of you, but then the input, transformation, output. This is called the transformative research, system thinking, system approach, a T-shaped thinking, and whatever you may call it, STEM-based thinking or STEM-based professional, etc. So I think this entire thing, we have patented it, and there are 2 more patents on the thermal aspects and many other aspects, tolerance, etc. So what I'm trying to convey at the bottom is a machine which was SH63, which was produced by the next gen, the MGT, that is Micromatic Grinding Technologies, and we analyzed it from all aspects of engineering. And when you do any project, you either do the finite element analysis or do CFD or a tolerance analysis or some blah, blah, blah. So, but then here, if you look at it, static rigidity, both kinematics and dynamics, static, dynamic, kinematics, and thermal. So this way we have been able to bring out these models which are shown at the bottom as error models, stress models, thermal model. And if you can develop all of them, then you know how to analyze a given machine. And if you develop only one, you do only part of the work. And this is where you can see at the bottom, we have brought out all aspects of the machine which should be improved from the existing level to the next generation precision grinder. This was a study which took almost 3.5 years, 2011 November to 2015 March. Then we went and made a presentation to the committee. Committee said, why don't you implement them? If you are so confident, why don't you take these ideas and implement it? We were already implementing at each and every level. Then company also came forward, yes, you give me 1 more year, a few more lakhs. And with that, we have built the machine. Next slide, please. And this was inaugurated by Dr. R. Chidambaram in 2016. After the machine, 2015 March it took place. And then it took 1.5 years, for us to prove all the capabilities by taking the components, by testing it. Next, please. This was the machine. And we could test it with 3 companies giving the components and also the tooling. And you can see the capabilities of this machine was in some cases better than the existing machines in 2016. But of course, the world is changing very fast. And today's precision levels are improving continuously. And if you want to really keep pace with the international developments, I think we have to keep working, and we are working at AMTDC. Next, please. I think this is when the Ministry of Heavy Industries brought out the scheme, and we got involved in those Center of Excellence since 2016. And during the COVID, technology innovation platforms. Then after that one, in phase 2, the industry accelerator, where robotics, every unit of it is being developed in partnership mode, with AMTDC contributing towards the design, analysis, and a prototyping. So as you see that we were involved in all these activities over the last 10 years since 2016. And you can imagine the involvement is in both phase 1 and phase 2, has focused on the technology development, skill development, manufacturing, industry 4.0, and the various things. Next, please. So I think initially we were lucky enough to get about 6 industries. And these are all well-known industries. Most of you might be aware of the machines being produced by them and supplied it to various institutions. MTAB was one, they were producing almost all the training kits and training machines and robotics and others. Jyoti heavy machines from Rajkot. Chennai Metco, they supplied to almost all the labs, abrasive cutoff machines, polishing machines, etc. for making the metallurgical samples. Then the ACE designers, CNC lathes, interface, they're into the controllers, drives, micromatic grinding. As you see, that 20% contribution comes from the industry. Then only the 80% will be given by the government. And that's the model which is working at this AMTDC. So it's completely not for profit, but then a lot of effort has gone in creating this entire, what do you call, prototype developments to the machine developments. And you can find all these machines. I think in the next few slides, you will see those photographs also. Next, please. It was inaugurated after the prototypes were made in 2019. The joint secretary, and then IMTMA presidents and our directors, and many of them have participated in the inaugural event. And you can see the view of AMTDC. So where we have machines on one side, robots and test rigs, etc. Next, please. So what are we? We are not for the TRL 1 to 3 or TRL 4 to 6, but we are focusing mostly on the TRL 7 to 9. And of course, unless we go through this TRL 1 to 6, we will not be able to produce them. But then that is part of our activity because the CG scheme is expecting us to develop the technologies. And in this process, we have been able to develop several technologies as well as several people who have worked both at industry as well as the IITs and other institutions also. A few startups and a few MSMEs also were supported through our efforts and our advice and consultancy, etc. Next, please. So I think we have a board like any other board. Of course, members are there from various industries and CMTI and ministry, everyone. So next, please. I think our approach, as I said, that system thinking. And of course, we have some advisors, as I said, Dr. Subbu, who wrote this book on system approach. There are several books on it, but then since he is directly dealing with the approach at the Saint Gobain, so he has helped us at many places during the reviews, and also, and he used to visit us every year twice, and now he's about 77 to 78 years old. And he has also written a book which was brought out by the ASME and Transformational Skills for the 21st Century Technical Professionals. I think you can see the innovation happens only when you define the problem very clearly and everyone speaks the same language. We call it as a common language. And knowing the capabilities of both the sides, we should know that what the academia can do it and what the industry can do it, what the testing units can do it. That's how the ecosystem has to be built. And as intellectuals, we are always satisfied with some sort of a development which is going to give us the happiness. And that's why we say the emotional intelligence for developing a new solution. Next, please. I think we started with only machines, but then today we are into the robotics, automation, and digital and smart manufacturing. So these are the three domains which the AMTDC is focusing. Next. And with the initial efforts being on the machine tool, looking at it from end to end in a holistic way, we have been able to build several capabilities which are shown on the outer rim of the entire the slide, where core capabilities in 4 different areas, as I said, the robotics, automation, discrete manufacturing, and smart digital manufacturing, and machine tools and machining. I think with these capabilities, we are approaching many MSMEs also to look at their problems and then provide any type of help that we can extend it. And that is continuing it with our own internal efforts. And anybody who has a problem can approach us, and we will study the problem and then offer the solutions to them. Next, please. And our projects are in 3 directions. Apart from the government funding some of the projects in partnership mode. We call those projects as the technology development projects. And since we have built certain capabilities, and these capabilities are going to be useful for any industry, and even some of the government organizations and defense organizations and Navy-based organizations, we offer them the turnkey projects to provide the solution from the requirements to the final product. And of course, some of the large organizations also approach us and do it. So please remember that it did not happen overnight. You see how much effort one has to put it in order to translate these ideas into prototypes and showcase it to them. None of them will give you even 1 lakh or 1 rupee under the CSR or anything. So now more than maybe 25 to 30 projects we have been able to complete it. And we are now offering this sort of a services to the MSMEs also. But again, it depends on their appetite and interest. Next, please. Several other initiatives are towards connecting the people through this platform known as the Technology Innovation Platform. This again, like any other platforms which we see it as a Google, LinkedIn, Facebook, etc. So this is based on the graph-based, concepts, and we are using it to connect the people and carry out some internships and others. And we also build this sort of a smart manufacturing experience center to help many faculty and industries and give them an experience at the center. And at the same time, if they have some specific problems, we can connect them to the people who are involved in our group as a special interest group. I think that's how we are helping many of them also at the center. Next, please. So please go through them. Yeah. A glimpse of our journey can be seen through various, yeah. Next, please. You can see the machines which are built in partnership mode. And in each of these machines, the periphery and dressing, the industry will do it. But the core, inner core technology, what is the orbital mechanism? How do you really build the machine with orbital mechanisms, designed and developed and prototyped? And similarly, instead of indirect drives, direct drive machines, it looks very simple when somebody says, but then if you wanted to really build the prototype and then make it into a machine, and now they're selling them not only in India, all over the world. And Jyoti, again, it's a multitasking machine for making the landing gears of aircraft and many others. Then you can see the Precision Micro Machining Center from bottom up. We have started from the bed to the various components and other things. Like now, we wanted to expand this one to various industries like Titan or micro hole drilling and micro machining, etc. Next, please. These are all the technologies which are actually denied to India, and we have come up with our own ideas and build them with the funding from the DRDO, funding from this one, and we have taken about 5 to 7 patents on each of them. Those patents are turned into startups, and one of our project associate has made this startup on the waterjet technology, Egohan Industries Association. Probably you can see it in Perungudi in Chennai. So I think he is only from one college in Chennai, Thangavelu College of Engineering, and today has become an entrepreneur. So this is where you have to incubate the ideas and give them some know-how. And this is completely, and we are competing with some of the German companies. And of course, we are putting our fight, and he's trying to do his best, to grab that. Next, please. This is again IoT-based systems and building the process intelligence, which is normally available with the expert, technicians. And we have captured everything and built the framework for one process. We are doing it for the polishing process, and we can do many critical processes. That way, we are building the framework for making the machines into smart machines, processes, into smart processes, and analyzing the systems, through the diagnosis and prognosis, etc. Next, please. This again a a machine which was given to us in 2016 or so. And we took 2.5 years in order to transform this into a precision machine, which was earlier giving an error of about 35 to 50 microns to 60 microns. And today, with this thermal compensation strategy, having IoT as well as the algorithms, with the AI/ML based, and that's producing an error of only 5 microns to 8 microns. Next, please. And we did the automation of the machines being supplied by the Chennai Metco for grinding, polishing, cleaning, again grinding and polishing. And this again concepts is being utilized by them to produce a variety of machines from 3 stations to 7 stations or so. And the marketing is done by them, and they do the commercial activities. And this interface worked on in spindle drives and axis drives. And we have the know-how here to give it to somebody. And MTAB, we started with only 6 kg and 10 kg, where we imported several units, maybe about 60 to 70% import content. And 30 to 40% is our indigenous content. But today we are reversing it through the industry accelerator. Next, please. So this is the second phase where we are working with Grindmaster, engaged in the super finishing technology and machine tool building, and Lokesh Machines from Hyderabad, again 5-axis vertical machining center for die and mold making. And you can see on the left hand side what technologies will be developing it, so that this company will benefit and the AMTDC also will benefit in knowing the know-how. Next, please. So we have built these technologies earlier, and we want to put them onto the machines and make these machines. I think we have already made it and exhibited it in the IMTEX also. And this is another project which is useful for the strategic sector and electronics industry and steel industry. Next, please. So as I mentioned, that the accelerator is basically to look at all types of aggregates, right from the mechanical, electric, to the controller, to the teach pendant. And it is again a partnership mode. You can see the aggregate developers like Prerana and Pragati Automation in Bangalore. And M2 Next is a sister concern of a Bharat Fridge Werner. And the end users are TVS Motor Company, Ashok Leyland, Mahindra, Tata Motors. They all wanted to put these robots manufactured in India. As you see that 4 kgs to 200 kgs, we're making about 3 types, 15 kg, 35 kg to 10 kg, so that they'll be placed in those industries. And probably in IMTEX, you can see these machines also. Next, please. This is the turnkey project which I mentioned for the ERCI, which is again located in Hyderabad, and the DST funded the institution. And we made it, and this is also located in the research park itself. And this is called the membrane type fuel cell, proton exchange membrane fuel cell. Next, please. And as I mentioned that, of course, probably some of you can see that, but you can skip that one. Otherwise it will, I think you can see the designing and development and testing and validating it end to end. And to make this fuel cell, probably you can quickly move this so that you can look at all of them. So if you want to really build, it took 3 years for us, but then the amount of knowledge that we have gathered and the experience that we have gained it, I know my team was going up and down every day. I used to get really disturbed in the sense whether they'll be able to make it or not. Finally, they delivered it, gave it to them. And this is where you can build the capabilities among the youth, the next generation people. And wherever they are there, I'm not expecting them to be here permanently, but wherever they go and whatever they do, it is going to really help the nation. And this is the type of talent that we need to build it. Next, please. Yeah, I think we did collaborate with the Fraunhofer when TVS approached us, and they are quoting very high for some consultancy activities. And I think we went in and then we could reduce their costs. And high-speed rail project between Ahmedabad and Mumbai, we're working on some activity with National High Speed Rail Corporation Limited, and a few projects, with the LAM research, which has given us to our faculty, and we have implemented some of them. Next, please. And we help the MSMEs, and I think you can see a range of projects here. And physiotherapy table, then machine tending for cotton making machines from Coimbatore. Next, please. So this is Adaya firm making the Arica leaf based tableware, and wherein we designed because it was taking too much heat and a lot of wastage, and these efficiencies is further improved. This is again knot tying mechanism from textile company in Surat. Next, please. Many of our faculty members developed some processes using the plasma. We converted these ideas into prototypes, and these prototypes are again placed in the laboratories so that they can give it to their research students and then produce out of PhDs. This is again from civil engineering. There's a 3D printing machine with a reinforced concrete. Okay, next, please. Next, please. Yeah, I think like this, I didn't want to get into all of them because it's a large number of projects we have carried out. I think I thought I will limit it to a few of them to give you an idea about how micro machining and startups like Agnicool, then HTIC, Healthcare Technology Innovation Center, Aerostabilis, again, another startup. Next, please. So this is again launched in 2022 with Tata Sons Chairman, Mr. Chandrasekaran. Next, please. And our mandate is to see that how do we give that sort of a assessment of MSMEs and their maturity and the digital transformation. Unless they transform their industry digitally using the computers and computer-based software and CNC machines and other things, they may not go in for this sort of a MES implementation approach. So, and I think these are the things that we do it at SMDTC to give them an education, training, and an experience, identify their problems which can be taken up as a research, problem, and helping a lot of small scale industries also to connect with the large scale industries, etc. Next, please. Next, I think this is the approach that we follow. Next, please. How to collect the data. So as you see that at the internal circle, you can see that there are professors with expertise and researchers sitting here, students who keep coming and going, and several alliances with various institutions and experts, advisors, and government funding, etc., the governing board. So you see that the ecosystem will connect you with almost 200 to 250 people in the country. And you imagine that if at different places, if such centers are established and people are there to steer them, I think it is going to be a big, activity. Next, please. So I think this is where I thought my experience at MTDC and also the efforts that we are putting it over the last, 10 years is a different experience altogether. I moved from a teacher to researcher to the consultant. Of course, as an administrator, I did, several things at IIT Madras, and as an entrepreneur and as an advisor to help many of them. So this is the storyline which I wanted to give it to all of you. So it is up to you how you take it further. Thank you very much.
Really appreciate all your sharing all your experience, such a wider experience. And any further questions, please, from the chat box. Krishnoni, please. There was 1 or 2 questions.
So shall I stop sharing, sir?
Yeah. We stop it and then maybe you can just put out those questions. Yeah.
Share with the participants, sir. Same presentation. Can we share with the participants?
Yeah. No problem. You can share it. Yeah.
Yeah. For all participants, we'll share you through your registered email IDs. So we'll get it today. Okay.
So there was a question raised by Mahalakshmi. The question is like, kindly provide some information about interdisciplinary research projects?
I think in each and every project, it is interdisciplinary. As you have seen in the robotics, we require mechanical structures, electrical drives, electronics controllers, servo drives. Then you've got the software, IT, computer science, teach pendant. All of them are being made here in partnership mode. And we involve a lot of young students and engineers from the industry also. And we also parallelly run the internship programs at the industry also with the money and the support of our team members. You can imagine that every project is an interdisciplinary project. Nothing is purely mechanical. So please think and tell your people that every discipline, including the electrical, electronics, computer science, if they stay in their own domain, doing their own work in coding and programming, they're not going to survive for long. If they want to become a lifelong learners and lifelong contributors, I'm not saying whether you want to do it or not. Life is decided by you. Whether you want to work up to 50 or up to 60 or 70 or 80. My professor who is touching 86, still is active. Why should he do? Because it is a zeal, it is a passion. So it is left to the individuals of how long they want to work. But however, and this sort of a orientation of interdisciplinary nature of working in every domain is going to help them in making them into real professionals, and that will be a fulfilling experience for everyone.
So maybe they can visit your laboratories or AMTDC.
Oh, they are most welcome. Anyone today, hundreds of people are coming. I am just looking around and then seeing it from Army, Defense,
Yeah, so for all the participants, it's a privilege for
students from
you
various colleges.
to
Our
visit this
center is going to be an
AMTDC
exhibition
center.
apart from our activity. Yes, they are most welcome to AMTDC.
Yeah, it is just exactly adjacent to IIT campus, and it is called. Once you want to go, they will give you the location. It is exactly adjacent to the IIT Madras campus.
Yes.
Same boundary.
No, they are free to visit us at any time, but let them send the
Request.
email request, and then our team will take care. Okay.
So maybe you can just post your email ID so that secretariat, that one. No, sir?
Yeah. secretariat@amtdc.org.
Yeah, please note that secretariat.
Secretary, all lowercase, @amtdc.org. Any other questions?
Dear participants, if you have any question, kindly unmute and please ask.
Sir's email ID is already posted, secretary@amtdc.org. You can note down participants.
Yeah.
Then I think you can go for closing up. Thomas or Krishnani.
Okay.
Very informative and inspiring session, sir. Thank you, sir.
Oh, I say my pleasure, but see, they have to inspire many others. That is my goal is.
And also, I strongly advise the participants, teachers, please visit the center. Then only you realize, because now in this audience, Dr. Krishnani, Dr. Thomas, myself, and few other faculty members from our Jyoti Engineering already visited this AMTDC 2 days. So that's why the relation also started. So we strongly encourage you, as well as maybe students also can visit the labs, I think. Correct, sir?
Many of them are doing their intern during the summer.
Yeah.
And afterwards, if they are free, they can also be engaged in some projects as the intern engineers.
What is the duration you recommend for internship, sir?
I think it ranges from 6 weeks to 8 weeks, because their vacation time they have to see, and we wanted to keep them during May, June, July. And some will come in May, June, and some will come in June, July. And I leave it to them, and at least
Do you accept 4 weeks, sir? Sometimes 6 weeks.
Let them come. I think our team will handle that. What they want to do it, how they will
Okay.
involve them. Okay.
So, thank you, sir. We are truly grateful for that comprehensive and illuminating session on IPR and technology transfer. Thank you, sir.
Yeah, thank you very much. I expect that many such centers should come up, for which each faculty member should put some extra effort, and that will at least boost the economy of the country through innovations and startups and entrepreneurships. If we don't do it, whatever money that is available in the government kitty through the proposals and others, it's not going to really help. So I wish them all the best and then see what we can really do together. Okay, thank you.
Thank you, sir. Thank you. Thank you very much.
Very much. Yeah. Bye. Yeah.
Yeah, thank you. So, dear participants, we will now break for lunch and please be back at 1:30 p.m. sharp for the session 6. Thank you.
Thank you.
Once
Bye.
again, thank you, sir. Namaste. Thank you.
Yeah, namaste. Bye. Yes.
Thank you, sir.
Thank you, sir. Bye bye. See you afternoon 1:30 for the lunch. All the participants. Feedback form, you fill it. Did you complete the first day's feedback form?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. Yes.
Okay, okay. Bye.
Thanks.
I'll
you, sir.
also go for offline. I'll come back. Bye.
Sure, sir. Okay, sir. Okay.